Hi everyone, in this video we're going to be reviewing Chapter 6 material. To get started, even before you start your own review process for this chapter, really take some time and write down all the formulas that go along with the confidence interval material. Chapters 6, 7, and 9 are probably the most formula-heavy chapters in this class. So I actually did that as the very first step in my review process here. I went through and I wrote down both the confidence intervals that we use to find the parameters for mu, or I should say the lower and upper bounds on mu. And that was really dependent on whether or not we knew the population standard deviation or we did not know the population standard deviation. That affected how the error was calculated, and then that'll obviously affect what we add and subtract from our point estimate. So we technically have two formulas that we use to find a C confidence interval for a population mean. Then we also have a formula for estimating a population proportion P, and that's with our point estimate for P hat, and we have a different error value to add and subtract from the P hat value. So to start with, I would go through and make sure you know how to use and understand all of the formulas that go along with the confidence interval material. And then I would also have, and this goes for Chapter 5 as well, I would also have a copy of the z-score table and the t-distribution table printed out. You can find these in your textbook. I'll show you where that's at real quick. From the course homepage, you would go to the chapter contents tab, and then at the very bottom it says appendices. And there is table 5 is the t-distribution and table 4 is the standard normal distribution. There's technically 2 pages with table 4 because you have negative z-scores and positive z-scores, and that's 2 different pages in the textbook. So 2 tables go along with table 4, and table 5 is the t-distribution with your degrees of freedom. So before you start reviewing or before you sit down and maybe do some homework and practice for this Chapter 6 stuff, I would definitely have all of this handy and available to refer to as you go through the problems. So let's go ahead and get started. Number 1, a random sample of 42 textbooks has a mean price of $114.50 and a standard deviation of $12.30. So random sample N here is 42. Sample standard deviation X bar is $114.50, and our sample standard deviation S is $12.30. Find a point estimate for the mean price of all textbooks. Well, whenever we say point estimate, we're looking for that unbiased estimator of the population parameter, and the most unbiased estimator for a population mean is going to be our sample mean. So in this case, C, $114.50 is going to be our point estimate for the average price of all textbooks. Number 2, find the critical value Z sub C necessary to form a 98% confidence interval. Okay, well, we know that confidence intervals consume that middle proportion of our standard normal curve, so I'm looking to shade the middle 98%. So our Z sub C values are going to be here and here. This will be our negative Z sub C score. This will be our positive Z sub C score. To create confidence intervals, obviously we want to add and subtract a positive error, so we're always going to go with the positive Z sub C. The easiest way to go about this is to use that inverse norm function that we introduced in Chapter 5. And in this case, we got to remember that the inverse norm is always assuming leftmost area. So if I'm trapping 98% in the middle, that means I've got 2% left over in the tails, one of which is down here, and the other percent is up here. So in total, leading up to the positive Z sub C score, I really have 0.99. Right, the 98% in the middle plus the 1% on the leftmost tail. So I want to do inverse norm of 0.99. So 2.33. It looks like A will be our answer for number 2. Number 3, a random sample of 42 textbooks has a mean price of $114.50 and a standard deviation of $12.30. find a 98% confidence interval for the mean price of all books. Okay, so we're still dealing with sample values, so statistics like n equals 42, x bar is 114.50, and sample standard deviation S is $12.30. And I want to create a confidence interval. Real quick, let's scroll back up to my formula sheet at the top. I want to be using this formula for the error, right? Because I don't know anything about population standard deviation. The value that I was given was a sample standard deviation. So I want to use the error formula that requires the t distribution. So my error is going to be a t sub c value, which utilizes n minus 1 degrees of freedom. And we're going to multiply that by the ratio of the sample standard deviation divided by the square root of n. So let's see, error is t sub c times s divided by the square root of n. Let's figure out what our t sub c value is, assuming our degrees of freedom is n minus 1, which in this case would be 41. Okay. Now I want to point out something from the textbook here. For 30 or more degrees of freedom, the critical values for the t distribution are close to the corresponding critical values for the standard normal distribution. So in other words, I want to use the last row of the t distribution here. Let me pull it up real quick. So at the bottom here, we're looking at the 98% confidence level, second column from the right there. We're scrolling all the way to the bottom. Our T sub C critical score here is going to be 2.326. 2.326. 2.326. Okay. We're going to multiply that by $12.30 divided by the square root of 42. So let's go ahead and punch that into our calculator and save that value. I'm going to show you how to store a value on the calculator so you're not constantly punching in a bunch of digits. 2.326. Multiply that by 12.30 divided by the square root of 42. So this is going to be our error value. I'm going to save this value by hitting the store button. It's right above the on-off key here. We're going to store this as the letter E. So I'm going to hit the alpha button, and then the sign button has the little E above it. That means anytime I press E on my calculator, it's assuming that I mean that number. So to create my confidence interval, I recognize that we are trying to trap the true average of the population. So I'm setting up this kind of a confidence interval. Mu is trapped somewhere between x bar minus the error and x bar plus the error. So I'm going to take $114.50 and I'm going to subtract my error value. And I'm going to take $114.50 and I'm going to add my error value. So this gives me a lower and upper bound on the true population parameter that I'm trying to estimate with this point estimate x bar, and the error tolerance, which is defined by my level of confidence. So $114.50 minus my error value. So to call it back, I'm just going to hit alpha E. And that's going to be my lower bound. If I hit second, the enter button, it's going to call back the last line that I just entered in my calculator. And I can just edit that by changing the minus sign to a plus sign so I can get my upper bound. So it's looking like with rounding, this is going to be B, $110.08 all the way up to $118.92. All right, number 4, determine the minimum sample size needed to construct a 95% confidence interval for the mean age of employees at a company. The estimate must be accurate to within half a year. Assume the standard deviation is 4.8 years. Okay, so scroll back up to my formula sheet here. I'm estimating the minimum sample size I need to estimate a population average. So it's looking like I'm using this formula right here. N is equal to our critical score times the population standard deviation divided by our error value, and then that whole ratio is being squared. So I really just need to know what my critical value would be for a 95% confidence interval, which according to my table is all the way down here at the bottom. The nice thing about the tables in the textbook is that it gives you this little cheat sheet of critical values, so you don't have to manually come up with them every time you have to do a confidence interval. For 95% confidence, my Z sub C score is 1.96. And my standard deviation is 4.8. I want to keep an error tolerance within half a year, so I'm going to divide this by 0.5, and this whole ratio is going to be squared. So in the calculator, let's do this. 1.96 times 4.8. That product I'm going to divide by 0.5, and then I'm going to square my value. So I can't ask 0.041856 of a person, so I always want to round up to the next nearest whole number. In this case, that would be 355 people. It's going to be my minimum sample size. All right, number 5, find the critical value T sub C necessary to form a 95% confidence interval with a sample size of 15. Well, if I'm talking about T-distribution critical values, I always know that my degrees of freedom is n minus 1. Which, if my sample size is 15, that means I'm going to have 14 degrees of freedom. So 14 degrees of freedom with 95% confidence is going to be 2.145. 2.145 is going to be B. Number 6, a random sample of 15 DVD players has a mean price of $64.30 and a standard deviation of $5.60. So N is 15, X bar is 64.30. Oops. And standard deviation for the sample is $5.60. Find a 95% confidence interval for the mean price of all DVD players. Well, again, this has to come from a T-distribution because all the values in my problem are from the sample, not the population. I don't know the population standard deviation. So again, I have to assume for the error we're talking about T sub C times S divided by the square root of N. Now, I just looked at the T-distribution for a sample size of 15, and the critical value was 2.145. So I'm going to recycle that information here. We're going to multiply that by $5.60 divided by the square root of 15. And that's going to be our error value. So let's find that real quick. 2.145 times $5.60 divided by the square root of 15. Our error is going to be about $3.10. I'm going to go ahead and store this as my new E value. And we're going to add and subtract this to our point estimate, which was $64.30. So X bar minus the error is going to trap the true average price of all DVD players, as well as X bar plus our error. So 64.30 minus our error will give us a lower bound of about $61.20. And we'll do this again, but this time adding the error, $67.40. So it's looking like A is our answer there. Okay, number 7. In a survey of 250 internet users, 195 have high-speed internet access at home. Find a point estimate for the proportion of all internet users who have high-speed internet access at home. Well, the point estimate for a proportion is going to be P hat, and that is X over N, the number of people who have whatever it is that the problem is asking for out of the total number of people that were surveyed. So in this case, 195 have high-speed internet access at home out of a total of 250 people that were surveyed. So 195 divided by 250 will be 0.78. 0.78 is B. All right, number 8, in a survey of 250 internet users, 195 have high-speed internet access at home. Find a 90% confidence interval for the proportion of all, so confidence interval for proportion of all internet users who have high-speed internet access at home. Well, according to my little formula sheet, let's scroll back up here and look at it. I want to be using this confidence interval formula where I'm doing p hat minus the error, p hat plus the error, where the error is based off of the standard normal curve, right? I'm using critical z values, and I'm multiplying it by a square root of the ratio p hat times q hat over n. Okay, so this is going to be the error formula that I want to use in this problem because I'm trying to estimate a population proportion using my point estimate p hat. So we're going to do z sub c times this square root of the ratio p hat and q hat over n. Error equals z sub c times the square root of p hat q hat over n, which in the last problem that we did, that's where we were finding our point estimate for the proportion. We already found p hat in number 7, and that was 0.78. So in this case, p hat is 0.78, which means that q hat is 1 minus that, or 0.22. Okay. Now I just need to look at my standard normal curve table for the 90% confidence z-score, or critical z-score, I should say. So for 90% confidence, that's going to be 1.645. And we're going to divide that by 250 because that's our sample size. Now this whole ratio is inside the square root, so you got to be really careful about how you enter these in the calculator. If you're doing this all at once, parentheses are your friend. So we're going to say 1.645 and then open the square root symbol and then open another set of parentheses because I want to keep the p hat times q hat in the numerator. So if I use grouping symbols around that before I use my division symbol, that's going to ensure that that product is staying in the numerator, and then I'm going to use another parenthesis to close the entire ratio, keep it under the square root. So 1.645, square root button, open a second set of parentheses and do 0.78 times 0.22. Close that, so I've got grouping symbols around the product, divided by 250, and then close the square root symbol. So our error will be about 0.0431. I'm going to go ahead and save that again, store alpha sign button, store it in the letter E. And we're going to add and subtract this value to our point estimate, which here is the p hat value of 0.78. So 0.78 minus our error and 0.78 plus the error. So about 0.737 to 0.823. So it looks like D is our value. All right, one more problem and then we'll call it quits. Number 9, you want to estimate with 95% confidence the proportion of households with pets. So I want to estimate a proportion. I want to be accurate within 3% of the actual population proportion, and no preliminary estimate is available. Find the minimum sample size needed. Okay, so I'm looking for N. I want to figure out how many people I need to ask to stay within 3% error tolerance, knowing nothing about any kind of survey that's ever been asked about this question before. And I want to do this with 95% confidence. So all of the things in the problem are going to help you set up the minimum sample size formula, which again, let's scroll back up and see what that looks like. Minimum sample size to estimate P, N is equal to P hat times Q hat times the ratio of the critical z-score divided by the error, and that whole ratio is squared. So again, the problem is going to set you up with all of those values that you need. If there's no preliminary estimate available, we always assume exactly half for P hat and Q hat. So P hat is going to be 0.5 and Q hat is going to be 0.5, and our level of confidence has to be given and the error has to be given. So you'll be given all the pieces of information to plug and chug in the minimum sample size for proportions formula. Okay, so let's go ahead and do this. P hat is 0.5. Q hat is 0.5, and again, that's because there are no preliminary estimations available. Our Z sub C value for 95% is 1.96. I want to stay within 3%, so I'm going to divide this by 0.03, and then we're going to square that whole ratio. 0.5 times 0.5 times 1.96 divided by 0.03, and that ratio is squared. So about 1067.1 repeated. Well, if I'm talking about surveying people, I can't ask 11% of a person, so I have to round this up to the nearest whole value, which is going to be C, 1068 people. So again, word to the wise as you're doing these types of problems, either for homework or studying for the exam, again, really take some time and come up with a formula sheet where you understand where all of those values are being used. The difference in the wording when it says confidence interval, am I creating upper and lower bounds of a proportion, or am I creating upper and lower bounds for a mean? If it's for a mean, do I know something about the population standard deviation or don't I? Right, all of those questions are going to lead you to different confidence interval formulas. And if you have those standard normal curve and t-distribution tables printed out and nearby, that's also going to save you some time on the exam instead of flipping back and forth through the ebook or some other website trying to find those values quickly. Have everything written out and in front of you beforehand. There's really no calculator functions that you have to know for this chapter. Chapter 5 was really where we introduced like the normal CDF and the inverse norm. You don't really have to use those functions in this chapter. You just need to be really careful with parentheses when you're calculating those error values. So be really mindful of that. So let me know if you have questions. Hopefully this review was helpful.